Okay, so we're going to be looking at the day one trig homework today. We're going to go ahead and start off. So we want to, whenever we're kind of dealing with a triangle, we want to label our sides. Remember that the sides are opposite the angle. So angle P opposite that is going to be side P. Opposite angle R is side R, and opposite angle T is side T. Okay. We want to be thinking about like those angles open up so that angle kind of extends out and encapsulates that side P. The sides are supposed to be lowercase, and then the angles are always uppercase. So once I have my sides, I can start talking about different relationships. So any of these relationships with the trig, the so, ka, toa, there's other ones too, but these are the ones we're focusing on. They're going to relate an angle with two sides. And depending on what sides I care about or that I want to use, I might want opposite and hypotenuse, I might want the adjacent to the hypotenuse, or maybe opposite and adjacent. I will pick a particular function, either sine, cosine, or tangent. So in this first one, it says do the sine of r. So angle r, it's capital, again, sine of an angle. So I'm going to, my angle r, and I want to use the relationship of sine. Well, how do I remember that? That's where the SOHCAHTOA comes in. So stands for the sine of an angle is going to be equal to the opposite side over the hypotenuse. So I need to know what are my opposite sides, my hypotenuse, and what are my adjacent sides for this particular angle. Now, the nice thing is that the hypotenuse, the longest side, opposite the 90, is always going to be the hypotenuse, regardless of what angle you talk about. So side P is always the hypotenuse. That never changes. It's all-time quarterback hypotenuse. The opposite side and the adjacent side depends on what angle you're talking about then, if you're talking about angle R or angle T. Because I'm talking about angle R, this angle touches two sides. It touches the hypotenuse, and it touches what's called the adjacent side, the side next to the angle, that side that touches the angle that isn't the hypotenuse. That leaves just the opposite side, which is the side across from R. So because sine wants to use the opposite over the hypotenuse, the two sides I care about are the side, the opposite side, the hypotenuse, the R, and the P. So sine of R, whatever these values might be, it would be R over P. This one, now the 2 and 3, they're moving to a different angle. They're moving to tangent and cosine of the angle T. So no longer am I doing R. I can erase adjacent hypotenuse because that's going to change. And I'm going to angle T now. And angle T, it touches the hypotenuse, but it also touches this side over here. So because it touches that side, that's the adjacent side. And across or opposite the angle is the opposite side. So again, how do I know what order to put these in? What sides am I going to use? The SOHCAHTOA is how we remember that. Tangent, the TOA, is tangent of an angle. TOA is opposite over adjacent. The O stands for opposite, A for adjacent. So I want the opposite side of T, which is T, and the adjacent side, which is R. So this would be equal to T over R. And then cosine of T, I'm using the same angle, but it's a different relationship. The cosine of an angle is going to be the adjacent over the hypotenuse. So that's going to be R over P. Moving on. I'll write my SOHCAHTOA again. This would be side E, this would be side D, this would be side M. Again, lowercase for sides, capital letters for angles. And then opposite the 90, if I kind of rotate this, you can see it again. Opposite the 90 is my hypotenuse. And maybe you can't tell right away, or sometimes it might be tricky. Sometimes if you rotate your paper around, so if I rotate this, you can kind of now see that this is that diagonal, that longest side, a little bit clearer. So that's the hypotenuse, and again, depending on what angle I'm talking about, I can then label my adjacent opposite sides. So the first one is cosine of D. Angle D is right here. So that means this is the adjacent, it touches it, and this is the opposite. Cosine is adjacent over hypotenuse. So this is going to be equal to the adjacent over the hypotenuse, m over e. I'll skip down to sine. Sine of angle D. So again, sine is opposite over hypotenuse, the so. So SOHCAHTOA, sine is opposite over hypotenuse. So opposite, D, over the hypotenuse, E. And then tangent of M. Well, we're talking about a different angle now, so I need to... Didn't have to erase the hypotenuse, though. So angle M is here. This means that side D is the adjacent and side M is now the opposite of that angle. So tangent is opposite over adjacent. So opposite of M is M, and then adjacent is D. In 7 through 9, it says use a calculator. We'll use Desmos to find the value of each, round to the thousands. If you round to the hundreds, that's fine too. I know it says thousands, but you'll be okay. Tangent of 47 degrees. So what this is saying right now is you have a 47-degree angle in your triangle. There is some ratio. Now I know because it's tangent, it's TOA, opposite over adjacent, that there is a particular number, so maybe it's like 3 over 2 or 5 over 7 or something like that, where there's a ratio between these two sides that would always be defined for a 47-degree angle if it's the opposite and the adjacent. So what that might kind of look like is if you have a triangle, and these aren't drawn exact, but if you have a 47-degree angle, let's just assume that, whatever it is, the opposite side and the adjacent, it's going to have a particular ratio, which we'll use the calculator to figure out, that would let me know that that's proper. I know that's the exact ratio for that angle. So we're just going to go to Desmos and make sure I'm again in degree mode. So I go here, click degrees, very important. Tangent of 47, it's 1.07. And we can do it to the thousandths, 1.072. So this is 1.072. So I don't know what that quite is, but let's just say, for example, maybe that's like 7.1 and that's a side of 6. Now if I did 7.1 divided by 6, let me get a calculator up. Say 7.1 divided by 6, that's 1.18. So not very close to this thing, but kind of close. So you can imagine, like, all right, there must have been some ratio where these things are somewhat close. Then sine of 53 degrees. Just going to plug it into the calculator. Again, you can click the keyboard icon and functions, and it'll have your trig functions there. So sine of, I think it was 43.682. Oh, sine of 53. Uh, 0.799. If you're rounding to the thousandths. Cosine of 11. Function, cosine. Make sure again you're in degree mode. 11. So if I'm rounding to the thousandths place, I'm going to make sure I go to, here's tenths, hundredths, thousandths. So I look to the right. 5 or more, this gets rounded up, so it's going to become 0.982. Okay. These ones now, so you were given the angle, you wanted to find the ratio. This is going backwards. You know the ratio, you need to figure out what angle would make such a ratio. So whenever you're trying to solve for the angle, you're always going to use your inverse functions. So I'll do it right out for this first one, but you're going to do the inverse tangent, which looks like it's tangent to the -1, but it's actually called the inverse tangent. And what you do to one side, if you're taking the inverse tangent on the left side, you have to do it to the right. And this inverse tangent undoes, takes out the tangent function, leaving you with just that A, or that angle A. So again, we're going to plug this on the calculator. Inverse tangent of 0.438. So I'm going to go on my function and click the inverse tangent, which is this one right here, that looked like the tangent to the -1. The inverse tangent, and that's going to be 0.438. So that must have been a 23.653 degree. So 23.65, whatever it was, 3 degree. So for this particular ratio, so for an opposite side and an adjacent side to be 0.438, when you do that division, that had to have been a 23.65 degree angle. There's no other way around it. Okay. For these other ones, I'm simply just going to realize, okay, I need to get to this angle. I'm going to do the inverse cosine of both sides. So A would be equal to the inverse cosine of 3/8. A over here would be equal to the inverse sine of 3/5. Okay. Plug it in on the calculator. Inverse sine of 3/5 gets you a 36.870 angle. And cosine of 3/8. So inverse cosine of 3/8 is 67.97, rounding it 67.976 degrees. Okay, and again, kind of what this symbolizes is, okay, cosine, SOHCAHTOA. Cosine was adjacent over hypotenuse. So you have some triangle, the hypotenuse is 8, the adjacent is 3. What type of angle would make this thing true is if you had a 68 or 67.976 degree angle. Okay, that's the only way that you could have a 3 and an 8. Because you are in a right triangle, you could use Pythagorean theorem then to figure out what that side would be. That would be the one side squared plus this side squared plus that side, or equals that side squared. So let's see, 9, so x squared minus 64 minus 9, that would be 55. And then x would be the square root of 55. So this side would be square root of 55. So you could actually, knowing an angle on two sides, you can figure out the third side and what the angle must be. Or just by knowing two sides of the triangle in the right triangle. All right. We talked about this in class. There's 3 types of problems then when you set things up that you're going to have to solve. There's 3 pieces of information. There's an angle and your two sides. Either the angle or one of the sides, the unknown is going to be in the top, it's going to be in the bottom, or the unknown is going to be the angle. Okay. And there's only 3 types of problems you can solve. We just saw the ones where you have to do the inverse to solve these ones. So that's just doing exactly what you did right up here in numbers 10 through 12. Do the inverse on both sides, you get your answer, make sure you're in degree mode. So I won't do those ones. These ones where the variable's on top is very easy. Just multiply both sides by whatever that number is in the denominator. So 28 times both sides, and your answer is going to be x equals 28 times 64 degrees. So you would plug that in on the calculator and round. The ones that are a couple more, or two-step ones, are the ones where the variable is in the denominator. My first step is going to be to multiply both sides by x, getting it out of the denominator. So now I have x times the sine of 24 degrees equals 12. And then sine of 24 degrees is just a number. I don't really know what that number is, but I know it's just some number. So the opposite of multiplying by that number is to just divide by that number. These cancel, and you get x equals 12 divided by the sine of 24 degrees. You would plug that into the calculator and get your answer. So there's just three ways you have to do it. If you're looking for an angle, like in 15 and 16, you do the inverse. If you have a problem where the number's in the bottom, the side that's known as in the denominator, just multiply it out, or multiply on the top, the numerator, cancel it out, get your answer. And then if you have the variable in the bottom, multiply by x on both sides, divide it off, you're good to go. Finally, we get to these problems. How do I rotate this thing again? Here we go. All right. So for each of these things, we're now going to say find the value, the missing value, and using trig. So again, trig is about relating two sides and an angle. We're not going to care about the 90-degree angle. What we are going to care about is one of the two acute angles. So you can start off by finding your angle that you care about. I care about the 43 degrees because it was given to me. You can then start labeling your sides. Hypotenuse, adjacent, opposite. Now again, I don't need all three sides because I'm only going to relate two sides in an angle. So the SOHCAHTOA is going to help me decide what relationship I should choose. I want to include the opposite side because that's the side I'm trying to solve for. And I want to include the hypotenuse because it's a known piece of information. So I need the one that does the opposite in the hypotenuse, so that's sine. So sine of 43 degrees would equal so opposite over hypotenuse, x over 10. Now you haven't solved for this yet. This is like in the previous section. You'd multiply by both sides by 10, plug that into the calculator. This one, angle's right here. Solving for x, the angle. Opposite the 90 is the hypotenuse. The side that touches it is the adjacent. This must be the opposite side then. I don't care about the opposite. I care about hypotenuse and adjacent because those are two pieces of information given, and the angle is the third unknown. So I need the relationship from SOHCAHTOA. That's going to be the A and the H, which is cosine. So cosine of my angle x will be equal to the adjacent, k, over the hypotenuse, 15. Whenever you're trying to solve for the angle, you have to do the inverse function to get x. This one, my angle is right here, the given piece of information. This is the adjacent side then, it touches it. This is the hypotenuse, and this is the opposite. I want the one that includes the adjacent and opposite, so A and O, or O and A, which is tangent. So tangent of 51 degrees is going to be opposite, TOA, over adjacent, x. And multiply by x on both sides, and then divide by tangent of 51 degrees to solve. So everything else is just the same idea. Find the angle you care about, label your sides. This would be adjacent, hypotenuse, opposite. Pick the correct version from SOHCAHTOA. Find your angle, label your sides, hypotenuse, opposite, adjacent, And you're saying, oh, which relationship is it that gives me the opposite and the hypotenuse? Just remember so, ka, toa. And then you can say, oh, I need the O and I need the H. That must have been sine. Okay. Moving on down to these ones. Find the area of these things. You kind of have two pieces that you're looking at. We're doing trig with right triangles, so that might tip you off that you should kind of fill that in. Make a right triangle. So now I have a triangle and a rectangle. Add up these areas. So what can I do here? Well, I know this is 6. If that's 6, that must be 6. So this area would be 6 times 14, which would be 84 centimeters squared. And then I want to know, let's see, if this is 6, that's x. I know this, if this length is 14, I know that this length is 14. And then I want to figure out, so area of a triangle, let's remember that formula. Area of a triangle is equal to 1/2 base times height. So to figure out the base, I'm going to be figuring out this base right here. So that's going to be my missing side, that x. So I'll break this triangle apart. Here's that 14 side. Here's that 56 degrees and the x. If you want to flip it over too, you could still do it that way as well. It doesn't really matter. So if I draw it just like they have it, here's your x, 14, 56 degrees. So there's my angle. This is here's the 90. So opposite the 90 is the hypotenuse. Adjacent, opposite, SOHCAHTOA. So I want the side that relates the adjacent and the opposite. Adjacent and the opposite would be tangent. So tangent of 56 degrees. TOA, opposite, 14 over the adjacent x. So I'll solve for this. Multiply by x on both sides and divide that off. So it'll end up being x equals 14 over tangent of 56. Get that on the calculator. 14 divided by the tangent of 56. And you get 9.443. So this length right here is 9.443. That's going to allow me to do my 1/2 base times height. So 1/2 your base, 9.443, times the height of your triangle, which is, this is the height at 14. Plug that on the calculator. So let's see, 1/2 times 14 is going to be 7, and then that was 9.443. 443 gives you 66.101. So 66.101 centimeters squared. So this triangle has 66.101 centimeters squared to it, and this rectangle has 84. You add that up, that should be what, 140, 150.101 centimeters squared. This one, find the area of the isosceles trapezoid. I think that's what it's called. So let's see what we can do here. Well, can drop that down. There is a formula for area of a trapezoid. Let's see if I actually need it or not though. 5 times 8, this part's going to be 40. Let's say, I know again area of a triangle is 1/2 base times height, so I need to figure out this base. So that's going to be x. Here's my angle, so that's the adjacent and the opposite side. So SOHCAHTOA, I need an O and an A, so it's going to be tangent again. So tangent of 40 degrees is going to be equal to the TOA opposite over the adjacent. So that base is going to be 5 over tangent of 40. Plug that in. 5 divided by tangent of 40. You get 5.959. So this base is now 5.959. So because it's isosceles, I'm assuming that means, well, I know it means that they are going to be the same. This would also be a 40. This would also be 5. But basically, once I figure out the area of this triangle, I can just multiply it by 2, so I get that 2 triangles. So 1/2 my base times the height. So it's going to be half of 5 is 2.5 times 5.959. Gets you 14.898. So that's one of your triangles. That's the area of one of these triangles, 14.898. And because you have another one here, that's also going to be 14.898. And so if we add all that up, you have 14.898 times 2 for the two triangles, plus the 40 for the rectangle. It's going to be 69.796. And area is always something squared, like inches squared, centimeters squared. So that's that.